Welcome back to another math video here at Math Rocks with Mr. Cox. This video is going to be about sequences. For instance, perhaps we have a sequence of 50, 60, 70, 80, and so on, or perhaps it's 8, 16, 32, and 64. We'll be discussing what are the names for each kinds of sequences and also how you go about coming up with the rules. So for instance, one rule would be 10n plus 40. The other rule would be 4 times 2 to the nth power. So if this is something that interests you, stick around and you'll find out all about it. Let's get it on! The first thing we're going to talk about is how to identify what kind of sequence it is. And there's two types. There's arithmetic, we call that, and there's another type called geometric. Now, arithmetic just means simply we're going to be adding the same number every time. We call that a common difference. And in geometric, it means we're going to be multiplying by the same number every time. So we would call that a common multiplier. So let's go ahead and take a look at these sequences here and see what type it is. So if you look at this one, we're going up 3, we're going up 3 again, we're going up 3 again. So our common difference here is adding 3. So that is going to be an arithmetic sequence. I'll put an A there. On the next one, we're going down 4, down 4, down 4. So our common difference is subtract 4. And I know I said adding, subtracting are really the same thing. So this is also going to be arithmetic. Let's look at the next one. If we go from 7 to 14, we're adding 7. From 14 to 28, we're adding 14. So this is not arithmetic because we're not adding 7 every single time here. It changes. However, we are multiplying by 2. 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56. So we have a common multiplier here of 2, and that would be what we call a geometric sequence. Over here, we're subtracting 60, then subtracting 30, so it's not arithmetic because we're not adding or subtracting the same number every time. However, we are multiplying by a half. So multiply by a half, etc., etc. So our common multiplier here is 1/2. Now I know we're dividing by 2, but we're always going to talk about geometric in terms of multiplying. So this is going to be a geometric sequence. And finally, the last one, this time we're adding 2, then we're adding 5, then we're adding 7. So obviously this cannot be arithmetic because we are not adding the same number every time. And we're also not multiplying by the same number. So this is actually neither, none of the above. So sometimes sequences will not be arithmetic or geometric. Let's go ahead now and take a look at this arithmetic sequence, starting with the number 14, then 20, then 26, and 32. So this would be term 1, term 2, term 3, and term 4. And every single time here, we're adding 6. So our common difference is adding 6. I'm going to go ahead now and I'm going to make a table over here. And you'll see why here in a minute. We have what we call the term number, or if you want T for shortcut, and the actual number itself. So for instance, we have term number 1 is a 14. And then term number 2 is a 20. Term number 3 is 26. And then finally, term number 4 is 32. So we could keep going and adding in more numbers, but we're not. But I want to ask you something. If I wanted to say, what is term 0? That would be the term that came before 14. And what we'd have to do is we'd have to work in reverse order. So instead of adding 6 every time here, we're going to have to subtract 6 to go backwards. So that would wind up being an 8. And then what I'm going to do here is we're going to take a look at this here, and we're going to see if we can look at this number 14 a little bit differently than the way it is right now. So we can think of 14 as that 8, that is the initial or 0 term, plus 6. We can think of 20 as that 8 plus 6 from the term before it, plus another 6. We could think of this 26 as the term before it, which is 8 plus 6 plus 6, plus another 6. And we could even think of this as 8 plus 6 plus 6 plus 6, which is the term before it, plus another 6. And why would we want to do this is simply, if we looked at this, this would be 1 6. This would be we're adding on 2 6s, 3 6s, 4 6s. So in other words, I could write this as 8 plus 1 times 6. I could write this as 8 plus 2 times 6. I could write the third one as 8 plus 3 times 6. And I could write this one as 8 plus 4 times 6. And what you should notice here is that every single time when it's 8 plus a number times 6, it's the same except for one number changes. 1 becomes 2, becomes 3, becomes 4, which, by the way, coincides with our actual term number. So that term number ends up being the multiplier times 6. So if I wanted to do the next one, term 5, I could shortcut it by writing 8 plus 5 times 6. Or if I want to do the 10th term, I could do 8 plus 10 times 6. And whatever answer these are, that would be exact. So this would actually be 38, just in case you were wondering, which makes sense. So we add on another 6. This would be 60 plus 8. That would be 68. So in a general rule here, if this was, we didn't know what it is, we'll just call it the term number is n, we'd say it would be 8 plus n times 6, or we could say 6n plus 8 if we just kind of jazz that up a little bit. So here's how we write the rule. We take this 6n plus 8, and we're going to write out the term of any particular number would be 6 times the number term it is plus 8. So this ends up being our rule, where 6 is our common difference and 8 is the initial term that actually wasn't in the sequence to begin with, but we consider that our initial term by going backwards one spot. Let's take a look now at how this would work with other sequences, and we're also going to find the 50th term using the equation once we've created it. So in this first one here, we're going to be increasing by 4 every time, so our common difference here is plus 4. And if we work backwards to find our initial value, that would be a 9. So our equation is going to be t of 9 equals 4n plus 9, where 4 is our common difference of plus 4 and plus 9 is our initial value. If I want to find the 50th term, in other words, if I want to find t of 50, what I would do is I would take 4 times 50 and I would add on 9. Now 4 times 50 is 200. And then 200 plus 9 is 209. So that would be our 50th term. If I want to do it over here, this time, every single time I am subtracting 10. So subtract 10 is our common difference. If I work backwards one spot here, I would get to 50. So that is our initial term. So therefore, our equation is going to be negative 10n. And then plus 50, where negative 10 is our common difference and 50 is our initial value. If I want to go ahead and figure out the 50th term, t of 50 in other words, I would take negative 10 and I would multiply by 50, and then I would add 50 on here. So negative 10 times 50 is negative 500, and negative 500 plus 50 is negative 450. If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show. All right, so let's see now how this would work in terms of a geometric sequence here. And it's going to work kind of the same way here. And I'll just go ahead and say we have a common multiplier every single time here of 3. So our common multiplier is we're multiplying by 3. I'm going to go ahead and make a little table here. So we have our term. We have term 1 is 3. Term 2 is 9. Term 3 is 27. Term 4 is 81. And we could keep going if we want. And we're going to use the exact same process as before, which is we need to have an initial term, which in this case would be the 0 term. So if we work backwards here, rather than multiplying by 3 every single time here, what we're going to do instead is we're going to divide by 3. So 3 divided by 3 is 1. And then, like I was saying earlier on the previous one with arithmetic sequences, how this works is pretty simple here. If you want to think about this as the initial term 1 times 3, that's what 3 is. 9 would be the one before it times a 3. 27 would be the one before it, 1 times 3 times another 3. And this would be the one before it, 1 times 3 times 3 times a 3 times another 3. And how we would write this as, this is 1 times 3 to the first power. This is 1 times 3 squared. This is 1 times 3 to the third power, and this would be 1 times 3 to the fourth power. So if we wanted to figure out our next one, which would be 5, we would say, this exponent here coincides with the term number, so therefore it's going to be our initial term of 1 times our common multiplier raised to the 5th power. Now 3 to the 5th power happens to be 243 times 1, so that would be our answer right over here. And if I want to do it for the nth term, what I would do is I would say is 1 times 3, and n is going to represent whatever term it is. So it's going to be 3 to the nth power and then 1 times that. So that means our rule would be t of n equals our initial term of 1 times our common multiplier raised to the power of n. That would be our rule here. So once again, 1 is our initial term and 3 is our common multiplier. Let's take a look now at some ones with geometric sequences, and here we're also going to find the 5th term. So in this case here, every single time we're going to be multiplying by 2. So our common multiplier is multiplying by 2. If I want to work backwards, I'm going to have to divide by 2. So what is 5 divided by 2? Well, that would be either 5 over 2, or if you prefer, 2.5. So what is going to be our rule here is going to be t of n. Since we're starting at 2.5, that's what we write first, and we're going to multiply it by our common multiplier raised to the power of n. Likewise, if I want to find the 50th term, or I'm sorry, the 10th term, not the 50th term, the 10th term, I'm going to go 2.5 times 2 to the power of 10, and it just so happens that happens to be 2,560. All right, let's switch to a different one over here. This time, our common multiplier is 1/2. So every single time we're multiplying by 1/2. If I work backwards, I would take 200 and I would divide by 1/2. And 200 divided by 1/2 is the same thing as 200 times 2 over 1. So that's just multiplying by the reciprocal, otherwise known as 400. So our initial term is 400. So our sequence is going to be t of n equals 400 multiplied by 1/2 raised to the power of n. And if I wanted to find the 10th term, t of 10 in other words, I would take 400, I would multiply by 1/2 raised to the power of 10. You'd need your calculator for this one. It ends up being 0.39065. So that's all you need to know about arithmetic and geometric sequences. Hope you got a lot out of this video. Hope to see you again soon. Thanks for watching.